Hi, my name is James Taylor. I'm the Senior Lecturer in Precision Farming at Newcastle University. I head the research group in precision agriculture there, as well as the general group in integrated agricultural production systems. I've been working in the area of precision agriculture and digital soil mapping since 1996, when I started an honours project at the University of Sydney. I have held postdoctoral positions in Australia, France, New Zealand, and the US before I took up my permanent position at Newcastle University. My interest is in how variable production is within agricultural systems, and I'm not particularly fussed about what type of system I work in. It could be viticulture, could be cereals, could be potatoes, could be other perennial horticultural crops. I've worked across all types of production systems. My main focus is on how you describe the variation in those systems, and if you can describe the variation, the within field, the within block variation in those systems, then you have a chance then of understanding how you might manage those systems site-specifically to improve production in terms of quality. Quality, of course, is really important in horticultural and viticultural systems. My role within the SCRI project is to lead the Spatial Data Technology group. This consists of myself and two Ph.D. students, Jackie Dresser and Claudio Piccinini, who are both based at Newcastle University with me. As part of this, we tend to spend a month or 6 weeks a year in the US with our collaborators here. The role that we have within the project is particularly important. Precision agriculture is not new. It's something that's been around for 25, nearly 30 years now. In precision agriculture, you have a process where the sensors, the toys in the fields generate data. That data needs to be transferred into information, and that information presented to the grower in the form of a decision. And that decision must be able to improve the production system that the grower is working in. If you cannot provide a decision, then the information is effectively useless to the grower. And if the grower cannot use the information, he's not interested in the information. So precision agriculture has been around for quite a while, but a lot of technologies are not taken up because there's not a clear decision process to the use of the technologies. The technologies that we see widely adopted, things like controlled traffic, auto steer technologies, have a simple decision system. I want to drive straight. It's not too hard to determine how to do that. So those technologies are well adopted. When you start to try to layer information into agronomic and viticultural decision processes, you end up with a much more complex system. And when you have a complex system, the decision process is obviously much more difficult as well. So the role of this group within the project is really to get to the point where we can make good decisions with the data. The Carnegie Mellon group are very focused on generating new sensors to fill information gaps in that process. The Cornell group and the group in California through UC Davis are interested in the viticultural questions. So we need to be able to provide the information in a format, in a way that allows them to try to solve some of the viticultural questions that they're asking. For the Carnegie Mellon group, we need to support them in saying, if you build a sensor, what sort of data is going to come out of it? What sort of density of data do we need? How do we process this data into an information layer that a decision can be made from? So the two PhD students are working broadly across these two areas. Claudio works very much to develop web services, working with geographical information systems, how we process this information and how we deliver it, how we take the information from the grower, put it into a service, and how we deliver that information back to the grower. Jackie's role with that is to develop what the actual service is. So she's working on methods and processes to interrogate the data so that it can be fed through to the sort of services that Claudio is building. As we build this decision support system, this spatial decision support system, we need to be very aware and very interactive with the growers and their needs. How much interaction are they willing to put into this system? Where can we make things effectively a black box? We know how the data should be processed. Do we want growers to have access to changing or tweaking or fiddling with information? Where is that suitable? Where is it not suitable? When we look at how the growers might want to use the information, what sort of systems will the outputs from this go into? If we are to generate prescription maps based on spatial crop load maps, prescription maps to do variable rate thinning of fruit or variable rate thinning of canopy, in what format should this data be presented? How is it most usable to the growers? If we don't deliver the data, if we don't deliver the outputs in a way that the growers can use, then the system will collapse. They won't use it. the information, the technologies themselves will be considered useless, and we go back to square one, which is not where we want to be. So the primary purpose of this group is to deliver a spatial decision support service and the web service that sits within. In addition to this, I'm using my expertise in the spatial analysis of agricultural data sets to support how the other groups do their in-field experimental designs. So how do we set up in-field experiments using these spatial data sets to better understand the responses within the field? If we manipulate crop load, what is the effect on quality? How do we optimize the sort of management decisions that we want to make? So this is a very innovative and a very new area where you try to understand site-specific response functions in the field. The research group at Cornell and the research group at UC Davis are very interested in these questions, but we have to develop the right protocols to establish these experiments in the fields and make sure that the data that comes off it can be analysed and effective research questions can be posed and answered. Between the two, the web services and the spatial data analysis, it keeps us quite busy and makes for a very interesting project.